So imagine using the exact same AI that generates pictures of astronauts riding horses to predict the next catastrophic Bitcoin crash. It sounds completely unhinged, right? But that's exactly what we're looking at today. We're diving into how diffusion models are crossing over from image generation straight into the absolute chaos of cryptocurrency markets.
Yeah, it's a really fascinating pivot because, if you look at how you traditionally predict financial time series using classical machine learning tools like LSTM or ARIMA, they fundamentally expect, well, a certain level of rationality in the market.
Right. And rationality is like not exactly a feature of crypto.
Right.
Okay, let's unpack this. You show a traditional forecasting model, a random 400% Dogecoin spike, and it basically just throws its hands up.
Exactly. I mean, those traditional point prediction models just break down completely when the data gets too noisy. And that is where generative denoising diffusion models step in. They basically extract actual structured signals from total market anarchy.
Okay, I have to push back here, though. How does a model built for generating pixels translate to a financial chart? Because my first thought was it's like filtering out background noise on a phone call, but that's not really what diffusion does, is it? Is it more like, I don't know, taking a fully built Lego castle, smashing it down into a pile of random bricks piece by piece, and then forcing the AI to learn the instruction manual in reverse?
Yes, that is the exact mechanism. What's fascinating here is that this is known as the sequential denoising process. The model takes real historical financial data, and step by step, it deliberately injects Gaussian noise.
Wait, Gaussian noise?
Yeah, just statistical randomness, basically. It adds it until the data is literally pure static. That's the forward process.
So that's the breaking of the Lego castle.
Right, exactly.
Yeah.
Then comes the crucial part. The neural network trains to reverse that specific process. It learns how to denoise the data step by step. By learning how to reconstruct the underlying structure from pure static, it figures out how to separate actual market signals from pure noise.
Like random panic selling or a brief FOMO spike.
You got it. It isolates the real signal from all that chaos.
Okay, here's where it gets really interesting, though. Isn't that a massively overcomplicated way to just guess tomorrow's price? Like, why go through the trouble of destroying and rebuilding data when you could just ask the AI, hey, what's Bitcoin doing at 9 a.m.?
Well, because guessing one exact price, a point forecast, is highly dangerous in a volatile market. If a traditional model just guesses tomorrow's price is $50,000, it's this rigid line that completely misses sudden structural shifts.
Right, because crypto never moves in a straight line.
Exactly. So diffusion models using architectures like Amazon's TS-Diff or Diffusion TS, they don't give you just one answer. They give you probabilistic forecasts.
Meaning they give you like a whole range of scenarios instead of betting it all on one outcome for you.
Precisely. They generate multiple potential future price paths, mapping out entirely diverse market scenarios alongside confidence intervals. It essentially hallucinates different realistic ways a market crash or spike could play out.
Oh, wow. So it captures those really sharp jumps that classical models completely overlook.
Exactly.
Okay, so you're getting like a multiverse of Bitcoin predictions, but what does this all mean for the everyday trader? Is this a silver bullet? Like, why aren't high-frequency traders just printing money with it right now?
Well, there are several drawbacks. First, diffusion models are computationally greedy. Rebuilding that Lego castle takes a lot of time. If a model requires, say, 1,000 diffusion steps to denoise, that's 1,000 passes through the neural network for just one forecast.
Which I'm guessing is way too slow for high-frequency trading. And what about something completely out of left field, like a major crypto exchange suddenly getting hacked?
Total failure.
Right.
Because generative models are strictly bounded by their training distributions. If an unprecedented black swan event occurs, the model can't accurately hallucinate a structural market failure it's never seen before.
Right.
Plus, they are heavily dependent on the specific market regime. So a model trained in a roaring bull market might just completely collapse in a bear market.
The sources did highlight a clever fix for the speed issue, though, using something called token merging. And just so we're clear, in this context, a token isn't a cryptocurrency coin, right? It's just a chunk of the time series data the model is analyzing.
Right, just a data segment.
Yeah, so by merging redundant chunks of data together, developers are speeding up the models by about 1.24 times without losing any quality.
Which really shows the tech is adapting. But if we connect this to the bigger picture, diffusion in finance is an evolution, not a revolution. It won't replace your fast, classical algorithms for split-second trades, but for scenario generation like stress testing a portfolio against thousands of realistic crash scenarios, It's unmatched.
Though the sources did have a quick warning.
Oh, definitely. If you ever see a model claiming 95% accuracy on predicting Bitcoin, run. It's almost certainly data leakage.
Data leakage meaning the developers accidentally let the model peek at the future test data while it was still training. Basically the ultimate cheat code.
Exactly. Always check the code twice.
Definitely something for you to keep in mind if you're evaluating these tools in the wild. But I want to leave you with one final thought from the research to chew on. Right now, these models are just looking at price charts. But imagine multimodal diffusion models that process different types of data all at once. We're talking about an AI that doesn't just read the numbers, but correlates them with social noise. Like a model that could actively generate a price forecast by directly reading the tone of a single Elon Musk tweet.
Cruelly navigating the chaos.
Exactly. Building the castle out of tweets and trend lines.